Hi, today we are going again to talk about money, and more explicitly about how to evaluate the cost of a system and how to establish a tariff system. Why to talk about a cost model? We saw in the module about collection and transport how the costs can vary following the decision we took, and much more following the decision we haven't taken. Waste management is a combination of logistic and treatment. For both logistic and treatment, cost calculation is a necessary information for the authorities having to take a decision and having to organize the financial system and make it sustainable. Cost calculation should present not only the investments, but also the yearly operation cost in terms of cost per inhabitant and of cost per ton. A cost estimation is also necessary to establish the annual budget, as well as to define how to finance it and what will be the level of taxes that we have to collect. This is engineering and good governance too. Cost calculation allows also to develop an interesting benchmarking, which consists of comparing his own efficiency to the efficiency of other towns, in order to learn from other best practices. Cost model is just a realistic calculation of all the costs of a system, but tariff setting is more a political decision. There are a large number of possible models of tariffification, depending on the local conditions, habits, politics, economy, and so on. We will just see some principle. We will not develop a high financial tool, but just try to fix some pragmatic consideration and how to use it. Investment costs are generally the clearest part of a system. Investments in mobile material like trucks or bins or other tools, but also construction costs of the infrastructure. Each investment has a life duration after which it is necessary to replace it. For example, uniforms and tools have to be changed once a year. Machines can be amortized over 5 to 10 years, and constructions are generally considered to be rebuilt or strongly renovated after 30 years. In this example, we can see a collection trucks of 7 tons with loading and compacting system for an investment of some $100,000 and lifetime estimated to 10 years. The yearly cost of each investment can be estimated in the first approach as the total value divided by the amortization period. In this case, we have $100,000 in 10 years, so we have $10,000 per year. In this example, we consider that the truck has no more value after 10 years. In other cases, when the interest rate is higher, we can use another formula, a little bit more complicated. In this case, using this formula with 5% interest, we get a yearly cost of some $13,000 per year. This is the average annual cost necessary to finance investment through a bank loan. In municipal management, the biggest investments are sometimes not considered at all because it doesn't appear in the yearly budget. This can create a financial problem when it will be necessary to buy new equipment. In other clever municipalities, the yearly investment costs are stored in a special fund in anticipation of future investments. To calculate the operation cost, we need some information. This information can vary from one city to another one, depending on local conditions. But the first basic information to calculate the operation cost is the estimated time of using trucks, machines, or treatment plant. As we saw in the collection and transport course, this time is strongly dependent on the waste quantities, the choice of machines or vehicles, containers, and local conditions like distances. Let's take our example of a 7-ton collection truck with bins of 1,100 liters. The collection truck has a compaction rate of 2.5, a volume of 16 cubic meters, and we can consider an average filling rate of the bins of 80%. With this data, we can calculate the required number of bins necessary to fill the truck, in this case 45. Then we can measure or estimate the time to load to charge one bin, 2.5 minutes. We can estimate the distance of the collection routes of 8 kilometers and an average speed during collection of 7 kilometers per hour. The same for the transport to the landfill. We can consider 40 kilometers, 20 to go, 20 to come back, with a speed of 50 kilometers per hour. And then we have also to consider the unloading time in the landfill. If we have a good truck, it can be reduced to 6 minutes. On this data, we can calculate the total time per one tour. In this case, it will give us some 4 hours for one tour, which is very good in this case, because in this condition, we can think to do 2 tours in one shift. Then we can calculate the total waste quantities of one truck. For that, we can measure the waste quantity in one full bin by weighting, and in this case having 140 kilo per bin. With our 45 bins to fill the trucks, we can calculate that we can charge 5 tons per each truck. The annual operation cost of each entity should include the energy or the fuel, the other equipment, and the maintenance and repair. In our example of a 7-ton truck working in 2 shifts per day, 7 days per week, we can calculate a total distances. Making 48 kilometers per day, we get some 35,000 kilometers per year. Considering a fuel consumption of some 45 liters per 100 kilometers and a certain price of the fuel, we can estimate the yearly cost of the fuel. Same with the tires. We can estimate that we have to change tires after 20,000 kilometers and that we need 6 or 8 tires, and we can calculate the yearly cost of the tires. Same with engine oil or hydraulic oil. We have also to consider the maintenance cost of the trucks. In this case, we consider a 2.5% of the initial investment for each shift, so it will cost some $5,000 per year in this case. And we have also to consider insurances and taxes, here some 1% of the initial cost, which give us some $1,000 per year. The taxes and insurances are strongly dependent from the country. Considering all these costs, we can calculate the yearly cost of one truck, here getting $30,000 per year. After the investment cost and the operation cost, we have now to calculate the personnel cost. Personnel cost is usually an important part of the cost, or the bigger one, but it depends strongly on local economic condition and labor taxes. We have to consider the salary, but also the labor charges, here estimated at 20%. We have also to consider the time of working in the week. In this case, we have to add 40% for working 7 days a week, and we have to consider a certain reserve of 15%. In our example of 2 shifts per day, we need to have 2 drivers with a certain salary. With this coefficient, by 12 months, it gives us a certain amount in the year. After we have to consider 2 workers for each truck, by 2 shifts there are 4, with a certain salary, with the same coefficient, we have the yearly sum for these workers. But we have also to consider a supervision and administration cost, with considering here 0.5 people for each truck and each shift with a certain salary and the same coefficient. Altogether, we have the total annual personal cost of $52,000 per year. Now we have all the elements to calculate the total annual cost of our track. With this annual cost, we can then calculate a cost per ton and a cost per inhabitant. Let's consider the investment we mentioned before, the operation cost and the personal cost. Altogether make some $96,000 per year. It's interesting to consider that personal costs are more than 50% of the cost, operation costs 30%, and investment costs only 13%. Once we have the total cost of the track, we can calculate the total capacity of the track, considering the 5 tons per track per trip, with 4 trips per day. In all the year, we get 7,400 tons per year. Then we can calculate a cost per ton. With amortization, it gives us $13 per ton, and without considering the amortization, it gives us $11 per ton in our example. We can also consider another scenario, having only 1 shift per day. In this case, we can calculate with the same model that we have some 15% more cost. If we consider another scenario, having no bins in the streets and using the double loading time, we will have only 1 tour per shift. In this case, we can show that the cost will be increased by 100%. In another scenario, we can try with 3 workers per tour and not 2, and in this case we have some 13% more cost. Then, with these same calculation models, we can evaluate different scenarios and propose to the municipality the best one. It is sure that the united cost and factors have to be adapted to every local cost and conditions, but the method is the same and allows to show what are the consequences of the different choices and to prepare the annual budget. Using this tool on a similar way for each activities, you can calculate the total annual budget. As mentioned before, the choice of the tariff system is more a political decision. The role of the engineer is to propose the different scenario, to calculate the necessary taxes to cover the cost, and to organize the tariff collection. The cost of the service must be financed by tariff collection or by other municipal resources. This is the first political decision to decide which part should be covered by tariffs and which part by other resources. There are 4 basic recovery principles for tariff setting. The first principle is the polluter pays system. The waste generator has to pay for its elimination. Second point is the transparency. Tariffs should reflect the cost, and the citizen should be informed in a transparent way on the cost and tariff calculation. Thirdly, the cost recovery principle. The amount of collected tariffs should be close to the expenses, not under, not over. Finally, the simplicity of the tax calculation and the tax recovery system is very important. Tax system should be based on the available data, and it is very important that the system is simple to operate. We will not enter in the definition of each possible system of tariffs, but perhaps just to consider some basic questions. First question is which part of the cost should be covered by taxes or by other resources? Also, which part of the cost should be covered by businesses or by families or inhabitants? Also, should all the citizens pay the same tax, or should the tax be adapted following the quality of services, the zone of the city, the frequency of the service, the distances of the service? Other important question is how to calculate the tax, per inhabitant or per family, or per bin, or per square meter of the main house, or in proportion of electricity or water use. Other question is how to establish and update the clients and billing databases. How to collect the taxes alone or together with other services like electricity or water. Other question is how to inform the population about the taxes and about the importance to pay the taxes. Other question is how to react when people doesn't pay. How to integrate the poorest people in the system. If the poorest people cannot pay, then the level of taxes of the other should be increased in proportion to cover the cost. As mentioned, financing of the waste management is generally the key factor of sustainability. Financing implies to calculate cost and budget, to calculate and define taxes, to establish a client database and a billing system, and to organize the tax recovery system. These are the main elements of the sustainability of a waste management system.